All right, I know this is kind of a tough homework, so let me go over a few of these questions. So number one is hard to calculate even if you know how to do it. So they want you to use 6 rectangles to create a Riemann rectangle estimate of the area under this curve. So you can see that this naturally breaks up into 6 pieces, right? 1, 2, 3, 4, 5, 6. And they say that they want you to use the midpoint rule, and so that means that the height of each rectangle is supposed to be determined by the midpoint of the interval. Okay, so that makes the approximation more accurate. We talked about that in class a little bit, I think. Okay, so we have to estimate what these numbers are, and so what are they? This top one is just a little bit less than 75. You have to keep in mind that this distance is 25, so this is approximately 68.5, I think. So 68.5, I'm just going to say that. And sorry, this pen, I need to figure out how to change these settings or something, because it's making these explosions when I put my pen tip down. I think you can see that, right? And it's irritating the crap out of me. So you need to estimate these amounts. Okay, and so let's call that one 68 and the other one 70. And this is supposed to be a comma, but it exploded when I put my pen down. And this one, and you kind of get the idea, all right? So just do base times height for each one of these rectangles. So you can see that each rectangle has width 5, right? So that means delta x is 5. The common width of all the rectangles is 5. So for each rectangle, just do base times height, where the height is determined by the midpoint. And when you get your answer, it's going to be in these kilometers base, the base units, sorry, it's going to be in these units, base units times height units, right? So the units, when you do all these base times height things, you're going to get the units kilometers per hour times seconds, because it's base times height. But to make this into the desired unit, the unit that you want is the distance traveled, so that the unit that you want is actually kilometers. And so to make this into kilometers, you have to divide your answer by 360, sorry, 3,000. I'll just write it down. Divide by 3,600. And the reason you do this is to put the units in kilometers. All right, so let's keep going here. I'm going to skip down to number 7. All right, so you have to compute this area using some basic geometry. And what do you know? You know some things. It says A is 6, B is 12. Okay, so it's talking about these things, right? Okay, and all right, so you just use triangle rules or whatever to figure out these areas. So what is the question? The question seems not to have printed. Maybe I can cheat and look back over here at the web page version. Sorry, you can't see this because it's in another window, but what we're supposed to do here. Okay, so the first thing is the integral from 0 to 6 is the first part. So this is supposed to be the integral from 0 to 6. Okay, so that means the integral from 0 to a, right, of f of x dx. And so this is a line. We could do this, using the fundamental theorem if we made up an equation for this line. Actually, the equation is given because we know this is the origin. But just using basic geometry, you can see that it's going to be 1/2 that's going to make one whole square, right? There's going to be another square, another square, another square. So what you basically got here is 4 of these little squares. And how big are they? They must be 3 by 3, right? They're 3 by 3. And so if you have each little unit square is area 9, and you have 4 of them, then the total area must be 36. And let me just, yeah, okay. So I am not checking my answer, so I could be wrong, but that makes sense to me. And probably now we have to do all these other parts. Let me just check back. The next one is the integral from 0 to 15. Okay, so this next one is the integral from 0 to 15 of f of x dx. Man, you know what? I hate Microsoft Windows. This works absolutely fine in Linux. So we go from 0 to 15, and that doesn't really seem to make a lot of sense, to be honest with you. Let's see. So b stops at 12. Oh, and then we go 3 more units, right? So what they want is the area under the curve from 0 to there. And again, we can just add up these little rectangles. Actually, we already know the area of this part, right? So it's just this part that's new. It's a little bit harder to see how these pieces go back together than it was before, because this is obviously half a unit, this is half a unit, so I could just add those together. So what should we do here? Well, we definitely get 3 squares here, right? So each one is 9. So that part where I just put the dots, that's area. 3 times 9 is 27. So let me just write that off to the side. And now I'll think about what the area of this part should be. So the base of, I'm going to think of this little triangle here, right? So the base is 3 and 3 again, so the base is 6. You just copy it over. So it's a triangle and the base is 6. And what is the height? The height is 3, 3, 3, right? So that is 9. And then you can use 1/2 base times height to figure out the area of this triangle. So the area is 1/2 the base, which is 3, times the height, which is 9, which is 27. Okay. So what do we have here? We have this part is 27, this part is 27, and this part is 36. So the answer here is 27 times 2. It's making me so miserable. Times 2 plus 36. And then you do the rest of these exactly the same way. So good luck. And let's go on to something else. So what's the next one? So it's okay. Alright, so this one is really similar. One thing that's a little tricky here is that you should count the area under the x-curve as negative, right? So this is pretty clearly a semicircle. In fact, they tell you, right? They tell you if you're not comfortable just assuming that. So that is a semicircle. And we have to count its area as negative. So this is the part between, how does this work? So this is 20 and it's divided into 1, 2, 3, 4 pieces. So each piece must be length 5, right? So this is 5, 5. Okay, so this is a semicircle of radius 10. Oh, it's making me so unhappy. Quit doing it. I'm going to scream. Okay, and maybe if I close this, I'm going to close this program and see if it helps at all. Okay, so this is an area. This is a semicircle of radius 10. So that means that the area of the semicircle is 1/2 of what the area of a circle would be. So the area of a circle, you know, is pi r squared. So it's 1/2 pi r squared. Here you can see that r is 10. But you have to be sure to count this as negative, right? So what you're going to get here is 50 times pi. But when you're doing your computations, you need to remember to count this as negative, because it's beneath the x-axis. Okay, and so I think that's the hardest part about this one. So let's keep going. Alright, so here is number 9. Evaluate the integral, and I can't see the integral, so I have to copy it off the other sheet. Hold on a second. So I'll go down to number 9, and the integral is the integral from 0 to 3. Okay, so I think I've got this right. So it's the integral from 0 to 3 of, and I can't remember it for long enough, it's 5/2 x minus 5. So 5/2 x minus 5 dx. And we know all kinds of ways of finding areas now. So how do they want us to do it? They want us to just use high school geometry. Okay. So that's what they mean by computing it in terms of area. So let me make some axes. All right. And we want to go from 0 to 3. Okay, so let's just put 3 here. 0 is at the origin. Now this is a line of slope 2.5 with y-intercept -5, right? So actually the y-intercept is going to be way down here, because I've already called this 3, right? So -5, this isn't going to be exactly to scale. Oh my god. Take me back to where I was. Where was I? Number 9? I just started doing this in Windows, I'm sorry, and I just completely hate it. So anything that goes slightly wrong just totally infuriates me. So let's make a line here of slope 2.5. Where does it touch the x-axis? Well, it touches the x-axis where you have to set this thing equal to 0 and solve. So let's see. We have 5/2. X is equal to 5 when we set it equal to 0 and solve. So multiply both sides by 2/5, and you get that x is equal to 2. Great, thanks for helping, stupid computer. X is equal to 2, and so here's 2. Alright, and so let me go ahead and draw the line in. So there's the line, and you can see that we have 2 triangles. Alright, so what we're going to do to figure out the integral is to figure out the area of this triangle, which is obviously this height is 5 and the width is 2. And we have this other triangle whose width is 1 and whose height is, you have to plug 3 into the function to see. So the height is going to be 15 over 2 minus 5. 15 over 2 minus 5. Okay, so just use 1/2 base times height to compute the area of each triangle. Remember to count the area of the triangle beneath the x-axis as negative, and there you go. Alright, so what else? And there's another problem like this. What's the integral for number 10? Yeah, so this one is a semicircle, so you just, number 10 is, it describes a semicircle of radius 2, and so just compute the area of a semicircle of radius 2. And what is number 11? Evaluate the integral. So this is a shift up of a semicircle. Let me draw a picture. Okay, so as you learned in pre-calculus, if you have something here that's describing a semicircle with radius 9, so let me kind of draw that, okay. So here is a nice semicircle, or it's supposed to be a semicircle, with radius 9, so that means like this is minus 9, right? And here's 0. What they want you to do is to find the area, by the way, I've pushed it up by 5 because it's plus 5. Okay, so now what we need is the area here on the left-hand side. That's what the integral wants. So all you do is you find the area of the box first, right? This is a nice box that's 9 by 5, so it has area 45. And then you add the area of this quarter circle in, and I'll let you do that part. It's not hard. Okay, and number 12 is really similar to number 10. If you have trouble seeing what the line should be graphed as, that's not great. But just to get through this problem, you could graph it on a website like foodplot. Okay, so let's keep going. 16. Okay, so 16 says, given that this, use this result and the fact that blah 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 together with the properties of integrals to evaluate. Okay, so basically what it's saying by properties of integrals, it means that you can break this thing up. And something's happened to my picture. Let me see if I can fix it by going down to number 16 in the homework. What is that number that's been erased in my PDF? It's pi. Okay, so it didn't print pi. So I'll come back here and change this to pi. You know, who does want their pencil to make some stupid splash every time you touch it down? It's so idiotic. Like, what purpose could that possibly serve? Okay, so break this integral up into 2 parts. So it works just like capital sigma. So this is one reason that I did capital sigma so heavily the first few days of class, because if you get used to manipulating capital sigma, then you already know how to manipulate the integral staff. So it breaks up just the way you would hope. Now sometimes when people are learning math, they assume that things work too nicely, but sometimes things really do work as nice as possible, and the integral is one of them. It operates on things in kind of a linear way. Okay, so great. All right, so now the point is that you have this formula, and it's telling you that this part is just 1, right? It's telling you that this number is just 1. And what else do you know? You know that this part, you can use this rule here, and so it's going to, using that rule, that gives you pi squared over 4 minus a squared, which is 0, divided by 2. And so the integral here for the stuff just under the bracket, you also have to multiply in -7, right? The stuff just under the bracket is pi squared over 8. And okay, so this part, this whole part is going to be 7 times pi squared over 8. Okay, so what you have to do, this part is 4, so 4 take away 7 times pi squared over 8 is the answer. Super fantastic. What else? 19. Okay. All right. So what you want to do here, instead of integrating from 0 to 8 straight up, first go from 0 to 6 f of x dx, and the point of doing that is because you can see in the definition of the function, the definition by cases here, the function has really nice form between 0 and 6. It's just the number 6, right? You really need to understand functions defined by cases. And I say that in such an irritated tone of voice because nobody ever does, but it comes up all the time. So all this means is that the function is defined to be 6 for x less than 6, and it's defined to be x for x greater than or equal to 6. So if you graph it, it breaks up into 2 parts naturally, right? There's the part that happens before 6. So here's 6, and so before 6, it's just the flat line y equals 6. Here's 6 on the y-axis. And then after 6, it turns into the function y equals x, which is, a line of 45 degrees. Okay, so here is 8. And what we want, is the area between 0 and 8. So first you add in the area of this box, and then you add in the area of this, I don't know the technical name for this, but you can see that this part is going to be what? A triangle with base 2. The base of this triangle here is going to be 2, and its height is going to be what happens when you plug 8 into the equation f of x equals x, and so this is going to be 2 also. So you have this triangle here with base 2, height 2. You can figure out that area, and you can figure out the area of these rectangles and then add them all up. Okay. If you want to do it just analytically, then what I was drawing here, so I'll just finish, plus the integral from 6 to 8 f of x dx. And so geometrically what that means is first do this part to the left of 6 and then add up the area after 6. So what else? Number 22. Okay, so it says suppose h is a function. Oh yeah, this is the one where they ask you to integrate h double prime, right? So let me go down to number 22. And okay, there it is. They want you to integrate from 0 to 4 h double prime u du. So I'm really surprised, actually. I've gotten a lot of questions on this one, and I would have thought that this one was one of the easier ones, but I would be wrong. So the integral from 1 to 4 of h double prime u du. Okay, so we just use the fundamental theorem, right? The fundamental theorem says that we just take the antiderivative of this. The antiderivative of h double prime is h single prime. So there's just going to be h single prime of 4 minus h single prime of 1 by the fundamental theorem. And that's it. So just look up what those numbers are up there. And so that should be good, right? So I hope that helps.